I'm now going to explain to you the process of translation, and we're going to take it slow because I think that's going to be a slightly longer. It's going to be a slightly longer video. So first of all, so that you understand where translation is happening, let's have a look at the cell over here. You see these all of these little dots here on the rough endoplasmic reticulum. Here I zoomed in. These little dots over here, these are ribosomes. Okay. And there are certain ribosomes that are bound on the rough endoplasmic reticulum, on the RER, like you see over here, and there's some free ones, like over here. And I guess maybe also these here. I think that's supposed to be a vesicle. Forget about it. The free ribosomes, they kind of float around in here as well. And you see there are certain bound ribosomes that are found on the RER, and what they do is these ribosomes, they make proteins. That's important. So, translation is therefore the making of proteins, and what you see over here, this whole thing over here, that is a ribosome, and I'm going to explain you first the parts so that later on I don't have to do this later on, and then it's easier for me to explain everything later. So a ribosome has down here this thing that I've made down here that is called the small subunit. Small subunit. And if this is the small subunit, then this here must be the large. And I'm a little bit lazy, I just called it SU. And it keeps on always making these weird lines, I don't know why. Okay, that's the large SU, and in the large subunit you see these three areas, and they are called, that's the, I give them names, I call this the E, that's the exit area. Then you have the P, that's the polypeptide area, and this one is the acceptor. EPA, that is my, just like the Environmental Protection Agency, okay, which, in the United States, the EPA. So that's the exit side, the polypeptide side, and the acceptor side. And what I have down here, this is this red thing, that is a transfer RNA, a tRNA, the T, a small t, this stands for transfer RNA. And this little circle here at the top is not a circle, it's my amino acid. Amino acid, okay, and they're pretty important. Both together, they also have a name, and I don't have a space to write this. Both together, this has a name. It's called. You might want to write it somewhere. Amino acyl tRNA. Don't you love it that they always have to invent cool names for everything? Okay, so that's how we everything together. And the point is the following: the point of translation is to take the info of mRNA, which we made, to make a protein. In other words, there are so many different proteins around. The ribosomes are to make them. They have to make them. How in the world is the ribosome supposed to know how to make the protein, right? Don't forget that a protein or a polypeptide, which is is made of a chain of amino acids. But how is the ribosome supposed to know which amino acids to connect in what way? Yeah, it's a little bit like asking you, can you please translate a book from one language to another language, but I'm not really giving you a dictionary for that. How are you supposed to do that? Yeah, if you don't know these languages, yeah? You might know, yeah, you might be the most intelligent person in the world, but if you're not given the instructions on how to actually translate that, if you're not given a dictionary, how are you supposed to translate it? Yeah? Same with the ribosome. I mean, how is the ribosome supposed to know how to make the protein? I mean, you got to tell it to, right? And this information on how to make the protein is on the mRNA. So the ribosome needs messenger RNA because it carries the information on which amino acids to connect together to make a protein. Yeah. So we somehow basically we have a lot of these tRNAs floating around with different amino acids, and and they basically have to be put together now into the correct sequence. Okay. And I'm going to, now that I have explained all of these terms here, I'm just going to start and I'm going to explain to you how this actually works, okay? So what I have over here, I have the small subunit, which I'm not going to label anymore. And the first stage of making a protein, the first stage of translation has a name, and it is called initiation. That's important. Initiation is, maybe you want to make a number 1 somewhere, okay? Because it's the first step. And what you have for initiation is you have the small subunit over here, and this small subunit now connects with the mRNA, which I'm going to draw over here. I'm going to draw, this is my mRNA. Okay, it's my mRNA. And you have over here a tRNA with the amino acid, and that's the first one. Okay, and the first tRNA has down here 3 bases. Yeah, that is important. And these 3 bases are called UAC. UAC. Okay. And these 3 bases down here are always so important that we give it a special name. We call this the anticodon of the tRNA, the anticodon. And this is of course our tRNA. And this is of course our amino acid. But why am I labeling this again? You already know that, right? And what happens now is the following: is that this the first amino acid here is inserted over here. Where on the mRNA we have an AUG. That is important. It's always AUG, which is the first one. So we have an AUG over here, and you can actually see that it fits, right? It's complementary. So what I'm going to do is I'm going to redraw this over here, and I have the UAC. And over here, yeah, you know what? I'm just gonna make this a little bit simpler. This is supposed to be, I don't know. It's still difficult for me to draw this. That, you know, I don't like this. Okay, so you might be able to draw this better. Okay, so I'm going to draw it like this. Still not good. I don't have a lot of space on my desk, so that's basically the reason. I've got the big microphone next to me, so that. Am I doing, I know what you're asking. Is Mr. Kim doing this deliberately to be funny? No, I'm not actually. So that is now my tRNA, and over here I have my amino acid, right? That's supposed to be the thing here, right? The anticodon down here. And the thing is the following, that it's complementary, so it matches, and it always starts at AUG. That is really important. Now, if this is our anticodon, what are these called here? These are our triplet. There are always 3 of them. That's why they're called triplets. Triplet codons. Okay, these are the triplet codons, and this is initiation. Okay, so no, we're not quite finished yet, because what am I still missing? Obviously, I'm still missing the large subunit. The large subunit is added, and this is called the initiation complex, is now finished. Okay, so that is where we are right now. Okay, so this is the start, and is where the ribosome looks for the first AUG and inserts the first amino acid here at the very top, and this happens to be, this amino acid happens to be methionine, MET. That's the name of the or methionine, some people call it. That's the first amino acid. It's always the first one. Okay, so that is step number 1. Okay, and next one is the following. I'm just the next one is called elongation, and that is maybe the longest and the most the longest stage. I still have over here in between, I still have my my mRNA. Okay, over here I still have my anticodons and codons from, and the first tRNA, and I'm just gonna draw this a little bit faster right now. Okay, nope, this is supposed to be the first. This is the first amino acyl tRNA down here. Okay, and what happens next is the following. The next one over here, let's say I have on the mRNA I have UUU over here, UUU, and what happens now is that the next tRNA with the amino acid is going to go in here. Okay, so I have over here another tRNA with another amino acid, and this one has AAA. And you can see that it fits in here. So what it will do is it will go in here, into the A site. That's the A, the acceptor site. Okay, and it will have an AAA over here. I have to move the whole graphics tablet ahead a little bit because I don't have enough space. Oops, this is always a, here we go. So I have over here now the tRNA in here. Okay, and what will happen and you see it's still complementary, it fits, another one won't go in here, and what will happen now is, and that's kind of important, it will now make a covalent bond here, and this covalent bond is called a peptide bond. That is a peptide bond, and we have now connected the first two amino acids together. Okay, so what is going to happen next? The next thing that is going to happen, we're still in elongation, and what I'm going to do now is I'm going to erase this whole thing here, okay? It's going to be the following, that, I need to erase this here as well, that after we've made the peptide bond, the amino acid is now transferred over here. Yeah. That's where the amino acid is. The UUU, everything has moved over by one. So over here, the UUU is over here. That is the UUU from the previous one, UUU. Yeah. And the empty tRNA from the previous session now moves into the exit site. The amino acid is over here, yeah, and is now expelled. Yeah. So we have the empty tRNA being kicked out. Okay. It's the, remember that was the AUG because we moved over by one. Okay, the empty tRNA is being kicked out, and the whole ribosome has moved over by one, and now we can attach the next tRNA. We'll go into the acceptor site, the one that is complementary. Yeah? And we have the next amino acid in here, and then again we have a new peptide bond being made. And the whole process repeats. This one, the whole ribosome moves over by one, the empty tRNA is kicked out again over the exit site. Yeah? And then at the end, what we will have is we'll have, I'm going to erase this again, because yeah, we will have then everything moved over again by one, we will have then 3 amino acids being connected here, and the whole process goes on. Yeah? So what you have to know is that for every 3 bases over here, for every codons, yeah, it codes for 1 amino acid. Yeah? That is really important. So for example, if you have a piece of mRNA which is 900 bases long, yeah, then you know that there must be 300, the protein must be 300 amino acids long, divided by 3. How long will it continue to do that? Until it reaches somewhere a stop codon. Okay? And there are 3 of them, and these stop codons, for these stop codons there is no tRNA. Yeah? And that is now the next step. That is called step number 3. This is called termination. Okay, that is termination is the last step, and what we have is the following. We're at the very end right now, and the mRNA is over here. Okay, so we're pretty much at the end. We have over here our tRNA. Okay, with this tRNA has over here the polypeptide chain growing out of the ribosome. Okay, pretty long, maybe 100 amino acids long, and then it reaches over here a stop codon. And there are 3 of them, and for this there is no tRNA. And what will happen is the following: a so-called a termination factor, that's a protein. Termination factor will go into the A site instead of a tRNA. So I'm going to draw this differently. So that's the termination factor over here. It's a protein, yeah, going in here. That is my termination factor. And this tells the ribosome that we've reached the end. And what will happen then is the following. Everything is going to fall apart. The large subunit, the small subunit, okay, the mRNA, and the finished polypeptide are all released, and we have our finished product. What happens now to the mRNA? The mRNA can of course and will of course be used again by a ribosome to make another polypeptide. So you can use the mRNA several times. Some people think, well, we're somehow converting the mRNA, we're changing the mRNA to a protein or a polypeptide. We're not doing that. We're just reading the information, and we're using this information to make a polypeptide. Okay? So that is translation, okay? A quick overview over translation. And important is the following. If they ask you a 3-point question, for example, explain what translation is, of course you give a definition, but then you can divide it into these 3 parts. Yeah? And another thing is the following. There are these translation tables where when they give you an mRNA sequence, where you can then determine the amino acid sequence from this table, okay? Important here is the following. You have a start codon, which is always AUG. You have a stop codon. There are 3 possibilities for that. Okay, and for the stop codons, there is no tRNA, and there will not be an amino acid inserted. Okay, so that is the whole process of translation. Okay.